Hey y'all, welcome back to Math Rescue. I'm Andre, a certified math coach. In this video, we're going to work through a word problem involving volume and polynomial. Because of the numbers in the model, we're going to treat the polynomial like a system of equations. Then we're going to solve it graphically using the Desmos graphing calculator. Once you see how the story turns into an equation and how the graph gives you these problems get way more manageable. Talk about it. All right, so we are working with a tank of water. The animals, which is a marine center, is designing a rectangular pool for a group of sea lions. For the animals to have enough space, the pool must have at least 1,200 cubic feet. So I'm thinking about like a big kind of rectangular pool. They give us the dimensions of the pool. So the pool is going to be 2x feet deep. Now you might be saying, how deep is that actually? Well, we don't actually know how deep that is. There's a variable in the representation of that dimension. So if x is 3, the depth is going to be 6 feet. If x is 10, the depth is going to be 20 feet. So the depth could vary. They're allowing it to vary on this model. Maybe they're not for sure yet on how deep they actually want it to be, but they have an idea. So they're able to use an expression, in this case 2x, to represent how deep the pool is going to be. So we actually have an expression for all three dimensions. Depth can vary. Depth is going to be 2 times whatever x is. Length is going to vary. Length is going to be 3 times whatever x is plus 4. And our width is also going to vary. From here, now that we've kind of read out the problem, we want to go ahead and write an expression representing the volume of the pool. So volume is equal to length times width times height, or in other words, length times width times depth. So I'm just going to go ahead and multiply those quantities. So I can say that my volume equal to my height, or in other words, my depth, times my length, times my width, and that's it. Now I have my expression for the volume. If you wanted to, you could go ahead and simplify this expression and multiply it all out. Because we're using a graphing calculator, it's not really necessary to put it in a different format. The graphing calculator will take it in this form. Now, this is the expression representing the volume of the pool. But we know that the volume of the pool has to end up equaling at least 1,200 feet. So to keep it simple, we're just going to say exactly 1,200. And so now we have a model, a full equation, that can help us understand the constraints for x in order to make this appropriate for the sea lion. We could do some rearranging and we could graph it in standard form, but we're not going to do that in this case. Instead, what we're going to do is we're going to treat each side of the equation as its own equation, and so its own function. So one of our functions is going to be the constant function, y equals 1,200. And the other function is going to be the polynomial sum. Y equals 2x times 3x plus 4 times x plus 2. And then I'm going to go over to Desmos and I'm going to type that into my Desmos graphing calculator. Now at first, when you type both of those functions, both y's, into your graphing calculator, you might end up something that looks like this top version. What that is that's the polynomial. Notice that we're kind of at 0, 0 here. We're at -2. Sorry, here's the y-axis. So notice where we're at on the y-axis. We have basically 2 to -4 that we could see on the y-axis. But the constant function that we're working with is all the way at 1200. So what you'll need to do is you'll have to scroll up until you get to 1200 on the y-axis. You can see here I have 1198. And what we're looking for, since we're solving this like a system, we're looking for the intersection of the two functions. So I have 1200 in blue, just a constant function, so it's perfectly horizontal. And then I have the polynomial in green. And so they only intersect once. It makes things really nice. They only intersect right here. And so this x value is going to be what I would consider the solution. So x is just about 4.8. So I could then use that. I can plug that back in here to figure out exactly what numerical value each dimension has to be. Good luck in math class. I'm Andrew, Math Rescue. See you in the next one.